Okay, so thank you for your time this afternoon. So my name is Ewart. I'm the Managing Director of Assentech. Been in the industry for 25 years and set up Assentech about 10 years ago. And we focused entirely on reducing emissions from tank storage applications since we've had the business, and we've had a particular focus on developing and improving that aspect of leak tightness of breather valves. So I sit on both the API 2000 and the ISO 28300 committees, and I'm leading two task forces at the moment to further develop the leak tightness testing on breather valves, really on the back of the work that I've done so far and stuff I'm going to talk about with you today. I'm also a member of Ewart, and we've developed and are now manufacturing the first fully automated test benches, and they're mobile and fixed, and we've got a couple of patents on it as well. So before I go into the presentation, we've been sort of looking very closely at how we measure and control flow through the test benches, and really where I'm going to in this presentation, and it really only comes into the technical detail about a third of the way in, and I'm trying, because I've been developing this myself with a couple of colleagues. Sometimes you feel you're too close to it and you can go off into a lot of technical detail without really putting everything into context. So I've done a few slides on just why we think that leak testing on breather valves is important. Okay, so David Attenborough has just said in his recent book he's published that we are the first generation to truly understand the impact we've had on the environment, and the last to be able to do something about it. And I'm definitely dedicating my career, or what's left of it now, to ensuring that we do what we can to produce technologies that can reduce emissions. And then, again, probably quite relative to my career, I'm 56 now, so given 1 hour to save the world, Einstein would spend 55 minutes defining the problem and 5 minutes fixing it, and that feels a little bit like where I am right now. I've spent a lot of my career trying to sort of work out how to make the most of breather vent function, and now we've got the solution. We're out there trying to get these into the mainstream and get people using them. Mark Carney, interesting guy actually. We all know him as the ex-governor of the Bank of England, but he's now UN envoy for climate action, and particularly with an interest in finance. So, and he says a lot here, and this presentation is available to anybody that wants this at the end of the this talk. So, but without going into the full details of that paragraph, at the end he says the companies who invest in, and that is essentially reducing emissions to the atmosphere and improving our condition currently, will be part of an overall solution, will be rewarded. And those who are lagging behind will be seen as part of the problem and will be punished. So it's an interesting aspect that we've all got a role to play in reducing emissions to the environment. And I am very much an environmentalist from a point of view of what we do. So principal aims for reaching net zero. So we're talking about emissions from tank breather valves, and there are a lot of tanks based around this country, and a lot of them contain volatile organic compounds. So there's a big part to play with the tank storage industry in terms of reducing emissions. So the reaching net zero, in accordance with the Paris Agreement, COP21, was not to exceed global warming target of 1.5 degrees C over pre-industrial levels. The initiatives are now in the mainstream. The whole industry has completely changed in the last 18 months to 2 years, and it's now part of the daily dialogue about how we can reduce emissions. I've been working on this test bench for 7 years, but now timing seems to be quite good for what we're doing. Adaptation, everybody is now looking actively to reduce the carbon footprint. Offsetting is a big part of that, and I genuinely don't fully understand what offsetting means, apart from some of the big operators are now planting forests in South America and things, but offsetting has a part to play in the whole way that we reduce emissions to the atmosphere. Investment is required now, and we've invested a lot of time into developing technologies to reduce emissions, and we want to see those rolled out. Current predictions and policies are likely to drive up temperatures exceeding 2 degrees, which will lead to extreme weather events and mass extinction. So, not wanting to sound extreme, this is quite important that we do something about it, and we've all got a little role to play. So from an ESG investment, so many of you may have kind of heard of this, it's environmental, social and governance advice. PwC are just about to start a recruitment drive for 100,000 new heads. Ernst & Young, KPMG, Deloitte are all doing the same. So all the big blue chip companies are now having to report and declare their carbon footprint and a number of metrics, all that have been agreed by the Intergovernment Panel on Climate Change, the IPCC. We've all heard about the IPCC on the news. So this is what the majors are saying. So everybody is on the route to net zero. Okay, so it's time. So our mission is to help investors improve profitability and safety by detecting and reducing fugitive emissions that can harm people, wildlife and the environment. So we want to be working together with our customers to get them on the road to net zero in our particular little niche of industry. We're very focused on a small niche of the industry, but we think it's an important one. So this discussion is about how technology has enabled us to see tank vent emissions and how reducing them is relatively simple and how this can be achieved. So this is just a cover sheet really for the start of the presentation. The next is really a breakdown of the areas the areas where we can help reduce emissions. So optical gas imaging, there are two camera technologies available. One camera is a long wave uncooled camera, which is generally used in the biogas industry. So it's for looking at, it picks up methane. And the video that follows in a moment will show you methane emissions. There's a shortwave cooled camera. Can be used to detect a wider range of volatile organic compounds. I should say that the uncooled camera is also used for detecting SF6, sulfur hexafluoride, which is used on on power transformers, that sort of thing. So yeah, so the third item there is the quantitative tablet. So some of the regulators are now seeking to act on measurement of emissions from tank storage or any sort of facility where there are leaks, and this quantitative tablet is now being used for enforcement. So it's quite an interesting piece of equipment. So how are we doing? How are we helping the industry improve? So we're offering technical advice and support. I've got 25 years plus experience in the industry, and every day I learn something new, and every day I share a lot of my experience with customers. So we want to share our knowledge and help customers use venting accurately and to get the most out of them. Written schemes of examination. So we're very keen to formalise tank vent assessments. So we've developed a 25-page written scheme of examinations, but so many customers have their own operational written schemes of examination. But even though these devices are working below 0.5 bar gauge, we still think that the principles of the PSSR 2000 in terms of written schemes of examination is important. So we work with operators to understand the potential limits. If we picked up a large leak from a storage tank, it may be that the valve is actually functioning correctly. It's just that the process pressure is working too high for the valve. So always understanding how valves work and the physics at play are important. Okay, so we worked with operators to fully understand their applications before we get involved with servicing or changing out devices to increase leak tightness. We use a lot of reference standards, but EMUA 231 is a great document, and it's free to download on the internet, and it covers management of agent plant working below 0.5 bar gauge. We conduct and advise on functional testing, fully calibrated with using fully calibrated equipment. And this is the bit that we found really interesting, and we've done a lot of development in that area. And this is to assess adjusted set point, seat tightness, and the measurement of the actual leak rate volumes, but again, which has become a much more popular request from customers. And then very, very importantly is about how the documentation comes out at the far end of what we do. So we can document all activities using calibrated equipment, and what details go down on that documentation is key. Okay, so here's a short video. Thermography is a very interesting science, and we've been now working with the FLIR cameras now for a couple of years, and we find the technology is absolutely fascinating. So just to give you a feeling for the type of process pressures that we're working with, average storage tank is going to have an operating pressure of about 20 millibars. Not enough pressure to fully inflate a party balloon, but it will lift a 25-meter tank off its base, or it will lift a 10-ton lifting force. It creates a 10-ton lifting force. So the pressures are tiny, but the forces are huge. So this is the quantitative optical gas imaging. So it's a tablet that fixes to the camera, and in this photograph is it's a shortwave camera. So this is a cooled camera, and it will give a quantitative. If you put in the basic details of the VOC, it will calculate the actual volumetric flow. Very interesting technology. So the tank venting standards that we work to, there is ISO 28300, which was launched in 2008. It's currently being reviewed for revision, and I'm on the committee for that. API 2000 is currently in edition 7. Started out live back in 1966, and it's now at 7, and 8 is coming up shortly, and I'm also sat on that committee. So just a brief history of leak testing. It's, even though it's not in common dialogue, leak testing was first listed back in 1966 with an API bulletin, and it has continued to evolve, and it's now in the current core standards for tank breather vents. What do they say? So they actually define what the allowable leak rates from a storage tank would be, based on size. So up to 6 inches, you're allowed to have 0.5 cubic feet per hour. 8 to 16 is 5 cubic feet per hour, and 16 inches, 20 cubic feet per hour, or larger than 16 inches. So just to put it in context, 0.5 of a cubic feet per hour is about the size of a shoebox, large shoebox. So that's the amount of air that's allowed to escape past the valve on a test bench during the test in order to pass the criteria. So it's quite a tight test. So some worrying facts. This is just to give you an idea of what we've learned in the last 25 years of operating in this industry. Of the 20 manufacturers that we regularly come across, only 2 undertake production test and leak and calibration testing of new valves prior to dispatch to the industry for standards for both pressure and vacuum. So, sorry, only 2 companies that do the tests properly, exactly to the standards. Okay, that's on both pressure and vacuum sides. We don't think it's a safe practice because it's no guarantee the valve has been assembled correctly. So unless you do a test at the factory before the valve is dispatched, you don't know that the valve's been assembled correctly. So, you know, you put it on your tank costs £1 million plus to replace, and you could pull the tank in because somebody's put the pressure pallet on the vacuum port and vice versa. And they will fit. Believe me, they do fit. Usually they've got the same seat ring diameter, so it's only the height of the stem and maybe the volume of weight would tell the difference. Because you're not going to get any documentation, you won't have any way to conform to ISO 14001. One of the really easiest hits for ISO 14001 for continual improvement is to produce leak test certificates for the valves. Critical asset documentation, service trails. So breather vents are often classified as critical assets under COMA, and you can produce a very easy trail of review and functional testing if you have leak test certificates, but you can't if you don't. There's no declaration of leak tests on a valve that's not been tested, so you can't use it as part of your DESIR review either. So again, it's just lack of documentation is becoming far more important. So our advice to anybody that operates a tank farm is always ask for the leak test certificate from the manufacturers. You'll get a lot of answers, shifty answers from some companies that will offer a certificate of conformance but refuse to declare what's actually done as part of that test. So we don't think they're worth having. And many of the manufacturers of the non-tested valves make extravagant claims on leak tightness, and we've tested most straight from the factory, and all of them failed even the most basic leak test. So there's a lot of smoke and mirrors in the industry. This is the Ewart 231 standard. Again, I'll repeat, it's also co-branded with the SafeEd IMG1, and it's free to download off the internet. So functional testing, and this is the bit where I get excited about, is that we've developed these devices to measure the functional performance of breather valves. As you'll see, the valve has to be removed from the tank. So this isn't something that you would normally do on a tank every year, unless you had a severe acid or something kind of process where you do need to strip down every year. Typically, a valve would need a full functional test every 3 years. So we can do 2-inch to 30-inch valves, weight loaded, spring loaded, pilot operated, and we can also test blanket gas regulators. The funny looking dartboard on the right side is for side mounted valves. So it goes in conjunction with one of the little mobile unit or the large static. Right down to basic forms. The breather valve, and I apologise for my rubbish graphics here, but yeah, so essentially all the test benches is you have a pressurized air supply, pressurized air supply into the valve with a mass flow controller and a pressure sensor. So what you record on the laptop that's connected with the test bench is the retained pressure under the valve under certain flow conditions. And the vacuum test is, again, you just pump air out of the test bench and it gets drawn in through the vacuum pallet. And again, you measure the pressure and you control the flow. Very, very simple. So we cover two elements of the valve function. You've got set point testing. So we fix the flow and you will get a variable pressure. So what we're looking for is the standards say that as you increase the flow, you should see a corresponding increase in retained pressure. The point where you increase the flow and you don't see an increase in retained pressure is what is defined as the set point. It's not like a safety relief valve where they pop open. The set point can be measured by weighing the pallet on calibrated scales, so it's a basic physics, mass times force times area, but the actual functional test must be done using air. Standards say that the set point should be checked using airflow. Well, why should you do that? As I've already mentioned, you've got to first check to ensure the valve was correctly set up. And then the second point is efficiency. Because the valve is a modulating valve, the set point and the leak tightness are very closely linked. On a breather valve, you can create whatever set point you want. It's just a matter of how much air you're putting through it. So knowing the airflow is absolutely critical. So leak testing, and this is the big part of the technology that we've developed within the test bench. The past criteria is that you fix the flow. So for example, if the valve is less than 6 inches, you fix the flow at 0.5 cubic feet per hour, and you measure the retained pressure, and it has to exceed 75% of the set point. The flow control must be accurate to 0.5 to 20 standard cubic feet per hour to replicate the requirements on table 10 of the standards. So we use multiple flow controllers, and they're mass flow controllers that will control the flow. And in the test bench, we use 2 mass flow controllers. And for high accurate leak testing, sort of getting down to bubble testing level, we have a 3rd unit that we put in there. Many customers are now looking for the leak rate at 90%, not 75%. So we have recently revised our mass flow controllers and pressure measurement so that we can go down to 0.04 standard cubic feet per hour. And the pressure sensors must be accurate for minus 300 millibars up to plus 1000 millibars gauge. And so we use 3 multiple pressure sensors, and the test bench automatically picks which pressure sensor it's going to use based on the criteria that you set in the valve, in the test bench. So why is leak testing important? Profitability. So the area where most operators are concerned is to ensure they run their tank farms as efficiently as possible. And this is all about sustainability, so accuracy of valve function is quite important. So From a quality point of view, volatile organic compounds will have light ends which evaporate first, so you can get batches rejected if it's off spec. So keeping those light ends in the tank is important. Water can be drawn into a tank when it cools down at night. If the valve leak tightness is good, the valve will sit at slight positive pressures during the day. When it cools down, it won't draw in wet condensate, and then you don't get the problems with oxidization, which leads on to the second one. So oxidization of both the liquid in the tank and also the inside of the tank, causing rust particles and contamination that way. And you've got a documented asset management system. So quality is documentation, so you can keep a tight record on what the function of your valves is. So sustainability in the environment, so ISO 14001 is important. Corporate governance, we'll talk about the ESG requirement shortly. Road to net zero, reducing odours, reducing the risk of Environment Agency and health and safety issues, related issues, enforcement, for example, is something you really want to avoid for your company. And obviously that has a knock-on effect on your public relations. So leak tightness is important on all these aspects. And then from a safety point of view, you've got your DESIR review, so you want to make sure that there's no flammable vapor clouds floating around your site. And also you've got the risk of long-term exposure of your staff to VOCs. I put in there 30,000 people per year die from air pollution. In fact, I think it's higher than that, but the vast majority of those are from road transport, but a lot have connections with volatile organic compounds. And that could lead to asthma, loss of concentration and consciousness, lung and heart disease and cancer. So yeah, volatile organic compounds are not good products to be breathing in on a regular basis. So testing. Efficient testing for set point and leak rate requires the pressure sensors within accurate range with minimal deviations. So that's something we build in, and the test bench automatically chooses the right pressure sensor for the range that you're seeking. And flow control is we're now working on a flow rate from 0.04 cubic feet per hour to up to 100 cubic feet per hour. The procedures, we don't recommend that you test pressure vacuum relief valves on safety relief valve test benches, because they're not calibrated for the very low flows or flow control as a normal breather valve would require. The additional information that operators are now looking for is not only do they want it to know whether it passes, but they're actually asking us what the actual leak rate is at the 75 or 90% of the process pressure, and or the operational pressure. So we can now measure that using mass flow sensors that are built within the test bench. So independence of results. So we built our first mobile test bench about 7 or 8 years ago. Now we've had a fixed test bench for many years, but we then developed this to a mobile test bench, and we had a manual version for many years. When we started investigating the possibility of building our own test bench to apply to the market, we decided to go down the automated route. And the reasons for that are here. So we wanted to be able to produce fully independent test results. We want to avoid any confusion with on site, so avoid the human error or integrity issues. I mean, when you produce a set of results, it could be if a valve fails that the operator may need to consider replacing that valve. So we want to make sure that the results that we produce are top integrity and they're fully reliable. Repeatable tests. We found that using rotameters, 2 service engineers can produce completely different leak rate results. And because the test bench we've developed has got artificial intelligence built in it, and it works on fixed algorithms, it will produce exact identical results every time it tests. So it's a full repeatability. We can remotely control it because it's cloud-based. You can operate it remotely if you choose to. It's not an obligation by the operator, because some sites we work with do not allow any computers to be connected to the internet. Test certificate is available immediately. So right at the end of a test, you get a certificate pop up on the screen, which you can then transfer by QR code from your phone, or you email it, and it can also be integrated with your ERP system. So we're talking to some valve manufacturers now about it going into their ERP system, or if you've got an asset management system where you're looking at aging plant, it can be integrated in that. So testing on a safety relief valve bench is not recommended. So this is typically something which could go up to 100 bar test pressure. We just don't feel they're the right type of equipment to accurately measure leak rates on a pressure vacuum relief valve working at 20 or 5 millibars. So here's an example of a test. I'll just quickly run this. So just to give you an idea of what we're looking at here, the black line is the valve set point, the blue margin is the allowable tolerance, plus or minus, and in this case about 5%, and the green portion is the allowable pass rate. So you'll see down here is 0, and as just here you see that the pressure is starting to increase, and the line will go up past the green and into the blue, and it should hit the black and then level off when it hits a set point. You'll then see a drop off of pressure as the test bench goes from set point test to a leak test. And then the pressure will increase very slightly over a few seconds to indicate what the reliable leak rate is. So just quickly get this. So you can see the pressure increasing. And this is what you'll get on the readout on the laptop that's connected to the test bench. So the valve was burped, and it now switches over automatically to the leak rate. So in this particular case, the valve, current flow is 0.5 cubic feet per hour, and the flow and the pressure, retained pressure increases very steadily now. So this valve was set at 25 millibars, and on the set point test, it achieved 25.45 millibars. And this is the retained live pressure reading of the leak test, and it's going to be around 90% of the valve set point. Once the pressure stabilizes, the test bench then automatically switches over into the vacuum test. Now, the interesting part that we've had, and this is one thing I wanted to talk to you guys about, was that we've used artificial intelligence and algorithms. So the test bench, once we put in the basic details of the valve, we hit go, the test bench will follow a programmed test cycle, and it looks for and it controls both flow and reads pressure constantly. And it learns from the process. So it'll look at the profile of the valve prior to the start, during the test, and it will make adjustments to flow based on what the profile is to achieve the fastest results. So the latest version of this test bench now is we can do a full functional test in less than 2 minutes. And that's a big leap forward for the manufacturers, because this is a test at the factory which can take 15 to 20 minutes with manual test control equipment. So you see the vacuum set point was, I'm just looking at this now. So we've got with the valve has got a vacuum set point of -3.7, and it reached -3.6 on the vacuum test, and it's now, the leak rate has gone into the 75% of set point, and it's currently at 2.88 and increasing. So I can see that this valve is now going to be a pass. So this is what you get at the end of a test. Apologies for the lack of clarity, but you get a full test report. There's actually a 3-page report. Page 1 is pressure, 2 is vacuum, and the 3rd page is a list of all the calibration, the pressure sensors and the mass flow controllers with their serial number and their calibration date, that sort of thing. And so you get a full profile of the pressure and the leak test results. That vertical line is where the valve goes from the set point test to the leak test. And it also has a QR code so that you can download it instantly to your phone if you need to transfer it or take it away. And we have some customers that won't allow us to put the valves back on the tank until they see the test result. So this is available instantly at the end of the valve test. Requires no input from the technician to fill out any forms. It's all there pre-filled in. So from a calibration point of view, what we've done is we've developed this calibration module that clamps onto the top of the test bench, connects with an RS232 plug to the test bench, and it follows the pressure. So when you connect it up, the test bench recognizes that the calibration unit's been connected, and it will automatically run through a test cycle. You get a blue line and a red line, and the blue line being the test bench, red line being the calibration unit, and they've got to track each other. And the test bench is designed to allow the tolerance to ensure that all the sensors on the test bench are matching those on the calibration unit. And for overseas operators, they could periodically send the calibration unit back to us for checking, but that means that they then don't need to send the actual base unit back to us at all until, or if there ever becomes a problem with reading the results. So here's just at the end of the presentation now, there's a case study. So this was on an anaerobic digester facility, and we were contacted by the Environment Agency and the operator actually at the same time to help them resolve a problem. They had some low-cost devices on site, and the emissions, the odours from that site were immense. And the health and safety executive was considering closing the site until they got a resolution, but we helped them solve their problem. So essentially, the benefit of the test bench was that they gave us the old valves to test. We also tested the new valves that went onto the tank to resolve the problem. So the old valves were low-cost valves, but they were also relatively low technology, so they had a high leak rates. So they leaked the equivalent. The cost to run those valves over 3 years, even though the valve was £2,950 at the beginning, the cost over 3 years to run that biogas, the methane losses were calculated with the cost and the servicing to be £20,824. The global warming potential, it produced 545 tonnes of greenhouse gas. So GWP is a global warming potential, which is the calculation that we have established, and it's standard calculation methods, and that is the equivalent of 108 double-decker buses. The valve that we replaced it with cost more money. It was £5,500, so over twice the price of the other valve. But then the cost over 3 years, including the servicing and the losses of vapour, was £7,058, with a global warming potential of 0.556 tonnes. So this gives you a nice warm feeling when you see what can be achieved just using standard technology. And this is the calculation. So this is how we arrived at these figures. They were both 12-inch valves. There's the price. Actually, I made an error. The price for the more expensive, the quality valve was 6163, but the end cost was huge. The cheap valve lost so much methane, and this was a biogas, an anaerobic digester site, so they sell their gas. So this was straight off of their bottom line. So the EA then came back to us and said, our work will stop thousands of tonnes of damaging greenhouse gases to the atmosphere, and they were very pleased with the work that we did. Okay, so thank you very much for listening to my presentation. I hope you found it interesting. I apologise if I've gone on a little bit. This is something we're very passionate about.